In this video, we're going to look at using the binomial distribution and specifically using the binomial CD and PD function. So to start with, how we know a distribution is binomial is if there's two outcomes. Either it can happen or it can't happen. For example, flipping a coin, it can either be heads or tails. If there's an unlimited amount of options, for example, like the height of a person, that's not binomial because there's more than two outcomes. Okay, so if x is less than 7, we don't actually include 7 in the distribution because binomial data is what we call discrete. That means that it has set values. You can't have values in between. For example, you can't get half of a heads or half of a tails when you flip a coin. You can either get heads or tails. In the same way, you can't get 7 here. You can only get values of 0, 1, 2, all the way up to 6. You can't get 7. So we're going to write this out as the probability of x being less than or equal to 6. The reason for this is we can only use the binomial CD function whenever x is in the form of being less than or equal to something or greater than or equal to something. You can never use it when it's in the form just less than or greater than. The PD function, a bit of a side topic, but it will help later on. You can only use that when you want to find the probability of x equaling a variable. So technically, you can find the probability of x equaling 0, 1, 2, 3, 4, 5, 6, and add all of them together. But it's quite a tedious process. That's why here we're going to use the binomial CD function. Now, when we use it, there's two different ways it can come up on your calculator. So I'll show you how it comes up on mine. For me, I go to menu, I go to the distribution section, which is 7. I then go down to binomial PD, and then I click variable, and then three different variables come up, x, n, and p. X is what you're taking less than or equal to, so in this case it's 6. N is the sample size, which is 8, and p is 0.55. In your calculator, there might be a difference. It might say lower and upper instead of x. The lower is the smallest that x could be. It's just a very, very large negative number because we're taking less than or equal to 6. So honestly, just put something like minus 999. The upper limit here is 6 because it can't be greater than 6. And then n and p are still the same. When you put those values into your calculator, whichever way you do it, by the way, depending on your calculator, you'll get a value of 0.157. And that's the probability for this first part of the question. Moving on to the binomial PD function now, because we're finding the probability of x equaling a variable. Oh, sorry, I just realized I used the binomial CD function for this. I apologize. I'm just going to very quickly do it using the CD function. So using those same numbers, you'll get 0.937. Sorry about that. Should be 0.937. Okay, now we're going to use the binomial PD function for part B. So again, I'm just going to go to menu, distribution. This time I'm going to use the binomial PD instead of the CD. Again, I'm going to click variable. Now, again, it gives you three options, x, n, and p. X is what you're making it equal to. In this case, it's 5. N, again, is the sample size of 8. P is the probability of it happening, 0.55. That gives you a value of 0.257, which is the answer to part B. Now, moving on to part C, let's think of all the x values are included in this. So 3 is included, 4 is, 5 is, but 6 isn't because x has to be less than 6. That means that you can find the probability of x equaling 3 using the PD function, equaling 4, equaling 5, and add all three of them together. Or if you want to be really crafty, well, x less than or equal to 5 includes 0, 1, 2, 3, 4, and 5. But we don't want 0, 1, and 2. So if we subtract from this probability of that x is less than or equal to 2, that'll leave you with the remainder of probability of x equaling 3, 4, and 5. So let's do that, and let's use the CD function. So once again, I'm going to go to menu, distribution, binomial CD, variable. First, I'm going to input in x is 5. Mine is in this format, but there is an easy way to do this actually. If you have lower and upper, it's actually easier for you. You can just put your lower limit as 3 and your upper as 5. But yeah, I'm showing how to do it with this method here, which most calculators tend to have. So 5, 8, 0.55. That gets you 0.78. Take away. And then you have to do the whole thing again with less than or equal to 2. So it's a bit longer of a process if you have this same calculator as me. 0.088. Let's say 0.09. And that equals 0.69, which is the final answer to this question. Moving on to this next bar, it says y has the distribution 10, 5 over 12. It's binomial again. Find the probability of y equaling 2. Again, here we just use the PD function because we're finding the probability of x equaling a variable. So let's go back to the PD function now. X is going to equal 2 in this case. Don't get confused between x and y, by the way. It's just the same thing. And then 5 over 12. That gets you a value of 0.105. as your answer to part A. Now the variance of the binomial distribution is given by sample size times probability, all multiplied by 1 minus the probability. In this case, that's 10 times 5 over 12, and then multiply onto that 1 minus 5 over 12, which is 7 over 12. When you multiply all those together, you will get, I'm just going to very quickly do that, 350 over 144, and that will all be equal to a value of 2.43. That's your variance for this question. Hopefully this video helped in dealing with the binomial PD and CD function for the binomial distribution. Be sure to leave a like if it did and subscribe. I'll post a lot more content with further maths. Thanks for watching your video. I hope it helped. If you have any tutoring inquiries for A-level further maths, be sure to hit my website up at www.excelineducation.co.uk.